Influenza is a highly infectious viral illness which is easily transmitted from person to person when an infected person coughs or sneezes. Viruses can travel through the air and remain live on a surface for up to 48 hours. Infection occurs when viruses enter the body through the nose or throat. Influenza viruses attach to respiratory tract epithelial cells, where they quickly replicate and multiply, causing inflammation. Hemagglutinin proteins within the virus shell bind to receptors on the surface of the host cell. The virus shell then fuses with the host cell membrane, enabling the viral genetic material to pass into the cell's cytoplasm. The infected cell becomes a factory, producing new copies of the influenza virus, which are released from the cell surface. Once released, the new virus can continue the process of infection via invasion of adjacent cells, continuing the cycle of viral replication and leading to tissue damage and inflammation. This infected individual begins to shed virus themselves through coughing and sneezing, potentially infecting others around them. Preventing viruses from entering the respiratory tract helps prevent them causing infection. There are several different types of masks currently available which are used to guard against infection. Surgical masks offer the least protection against the transmission of the influenza virus. They're not designed to protect the wearer from inhaling infectious particles. They can prevent hands contaminated with influenza virus from coming into direct contact with the wearer's face. FFP2 and FFP3 respirator masks, also known as N95 and N99, were originally designed for industrial use to protect the wearer from airborne particulate hazards such as dusts. They are designed to prevent particles being drawn in through the mask fabric. However, a standard uncoated FFP2 mask has been shown to allow significant quantities of influenza virus to pass through the mask and be inhaled by the wearer. Little work has been conducted to show the filtration effectiveness of masks against influenza viruses. Furthermore, influenza viruses are still able to settle on the surface of standard FFP2 and FFP3 respirator masks, where they can remain viable for up to 48 hours, continuing to pose a risk to the wearer and others. Inactivating influenza viruses on the surface may reduce the risk of infection from handling and disposal of contaminated masks. Acti Protect respirators protect wearers by preventing influenza virus passing through the mask and help reduce the risk of infection through handling of contaminated masks. The Acti Protect respirator mask is made up of 4 functional layers. The outer layer is coated with GlaxoSmithKline's ViraCoat, which rapidly inactivates influenza viruses. The ViraCoat layer creates a low pH environment on the mask surface. This breaks down the virus shell, inactivating the virus. ViraCoat is non-irritating and non-sensitizing. The physical filtration layer contains electrostatically charged fibers, which trap small particles. This provides the filtration capability of the FFP2 respirator mask. The remaining 2 layers add comfort and protect against moisture ingression and absorption. Acti Protect respirator masks prevent influenza virus from passing through the mask and are active against all influenza strains tested, including H5N1. 20 flat-folded Acti Protect respirator masks are polythene wrapped together and packed in convenient stackable boxes. They're easy to use and comfortable to wear and can be fitted to a wide range of adult face shapes and sizes. Simply follow the fit instructions in the Acti Protect packaging. It's good practice to wash your hands or use a hand sanitizer before handling the Acti Protect respirator mask.